Then I will talk about what is stem cell. The normal cell, for example, skin cell and muscle cells and the new cells. Normal cells are the dividing. Cell dividing is normal cell and normal cell. This is usual, okay? But stem cell is the one is it's one itself, stem cell, and the other is other kinds of cells. For example, the stem cell is the next is what is ES and iPS cell. This is main theme is of my presentation. The first ES cell. ES cell is the made from oven. Do you know oven?
Did you say?
Yes.
Oh.
So ES cell is the made from oven. This is ES cells. And the next is iPS cells. iPS cells is normal cell. The I said skin or hair or muscle. From to Yamanaka factors are introduced to normal cells. Then iPS cells is made. This is very fantastic. So fantastic function is occurs in the cells. The next, development. Why development is important to explain about the ESL. The fusion of sperm and ovum is called fertilization. Fertilization is the fusion. The ovum which has already fertilized is called fertilized egg. It also says ovum. Fertilized. The egg is also ovum, also called ovum. This is sperm of human and ovum of human. And the cells of fertilized egg start small cell dividing and increase its own amounts. The increase the cell amount 2, 4, 8, and many. But the cell don't grow. The size of cell is the same size. This form of cell dividing is called segmentation. Please look at this figure. The two cell stage is the same size, and 4 cell stage also. All cells is same size, and the neural stage also. This is very important. Then the ovum again and again this style of the cell dividing. Then I will talk about the lecture of iPS cells and its lecture point.
Human embryonic stem cells have the capacity to become any cell in the body. This means they have multiple potential. The term for this is pluripotent. There are 4 types of pluripotent human stem cells, 3 of which...
This is the interview of Mr. Yamanaka, but I have no time, so I skip this interview. Then the point of lecture. The iPS cell is made by introducing some transcription factors in the normal cells. Then iPS cell this transcription factor, iPS cell needs this transcription factor, OX34, CNIC, and nano being 28, the CLF4. Then, how make iPS cells? This is a figure of using retrovirus. This is one method of making iPS cell. The next is the centivirus. Both methods are using virus, but recently new method has been invented using the plasmid. Do you know plasmid? In the E. coli. Conclusion. ES cells are made from fertilized egg. The iPS cells are made from normal cells. The OCT4 and SOX2 are fundamental to induce stem cell. There are some methods to make iPS cell, but these have cancellation problem. So in this scene, in this time, I will search about this cancellation problem. This is the references. Thank you for listening.
Do you have any question?
Thank you, Takahiko. Your presentation is very easy to understand. I have one question. You said iPS cell have fantastic functions through Yamanaka factor.
Yes.
So I don't know much about iPS cell.
Yeah.
Please, what is the fantastic function concretely?
It's a good question. Why I said fantastic reaction? Because there are we can know what is reaction, what reaction is occurred in the cell. So I said fantastic. So it is must be studied and it must be cleared in the future. So I'm very interested about it also.
Thank you. Thank you, Takahiko. It's great presentation. It's easy for me to understand thanks to your explanation. I have a question. Which is iPS cell and ES cell easy to make amount of step expensive, which is iPS cells and ES cell to make easy to make.
Which is easier to make. Okay. It's difficult. ES cells is made from ovum, and ovum has already had the multi-parent. It means ovum can be many kinds of cells, but iPS cell is the addition to the multi-parent the characteristic. So I think I remember the data of iPS cell the data shows the IBS cell is difficult to make because the addition to the multiple characteristics. So ESL is easier to make.
Many factors.
Yes.
Thank you. Thank you, Takahiko. I understand the IBS and ESL.
Thank you.
ESL is made of organ. An organ transplant may cause rejection. Do ESL cause rejection?
Rejection. If the ESL put in the other human body, then the ESL occurs the rejection. You mean? Yes. But the ESLs ESL has many types of ESLs. So wait a minute. In this video,
means they have multiple potential. The term for this is pluripotent. There are 4 types of pluripotent
Yeah.
human stem.
this type is the ESL, and this is the normal ESL. But the second nuclear and transplant stem cells is the ESLs. There are ESLs, and for example, my cells of nuclear of my cells are put in ESLs, and the increase the ESLs and the ESLs put in my body. There's no rejection because this NTS cells has the same genes of the same gene of me has my gene, so there's no rejections.
Oh, thank you.
Thank you. Your presentation was very good.
Thank you.
Yeah. And maybe I hear ICM and T
Yeah.
change, both change, but ICM only ICM change ES.
Yes.
So TE, what TE change to?
Oh, good question. If the organ grows usually grow, organ becomes skin and other tissues, and ICM also grow other tissue and lung and others. So the difference is between T and ICM is only OCT4 is evolved. The OCT4 is the most important factor of ES cells. So T has the multiple characteristic, but there's it don't have the OCT4, so T can't become to ES cell.